Oh, hi there. Welcome. Thanks for joining me. Today's episode is sponsored by the pooping bacteriophage, as well as sick, killer, awesome origami skills. Icosahedrons. Rocket! Let me get rid of that bacteriophage. We don't want it. It's disgusting. It's dirty. Hang on. So revulsive. It's way better. Let's use some like that bacterial soap stuff. Uh, Never have too much Germix in this life, right? Right, I'm going to show you two rules. They work with fractions in general, and they're also going to work with polynomials. If a polynomial is divided by another polynomial, is being multiplied by another polynomial, divided by a polynomial. I've already confused you. Don't want to do that. Okay, here are my two rules. As long as A, B, C, and D are non-zeros and stuff, especially B and D, multiplication of fractions or polynomials is a piece of cake. You just multiply straight across. This is on your sheet, your reference guide. This is just A times C on the top and B times D on the bottom. Now that looks simple if that's just fractions, like 1/2 times 2/3. That would just be 1 times 2 over 2 times 3, right? That's not what we're talking about today. Oh my, no we're not. We're talking about a problem like this. A polynomial divided by a polynomial times a polynomial divided by another polynomial. Oh my heavens. All right, well, though, we'll just simplify and one step at a time, right? The other rule is this. What if we got a fraction divided by another fraction? Maybe it's set up like this, which is really kind of messy. I don't like that. I'd rather go sideways with this thing. Two things we can do here. We can realize that it was that problem there, A over B over C over D, and come up with A times D over B times C. That's on your sheet. That's the shortcut for dividing a fraction by a fraction. But what really we've got going on here is division. Now listen, and you should write that down. Division is multiplying by a reciprocal. It's the same exact thing. And you were taught this way back in elementary school, that we would take that dividing by and multiply instead, but we're going to flip that. I'm going to flip that second fraction upside down. So we get AD over BC, which was the same thing as me taking that shortcut on that fraction. Now it is a little bit messier because we're talking about polynomials rather than just fractions. So applying my division rule, I would have this problem right here that I'm going to have to invert. I'm going to have to reciprocate the second part before I start combining and cleaning this thing up. So I'm going to take these two first. And then we'll take something that's more polynomial-ish, like quadratics. X squared plus x plus a constant, ax squared plus bx plus c. And we'll throw those in there because these are just a whole bunch of x's and y's, and we can put these all together. Let's start with these, though. It's just a good idea to start with the ones that we kind of recognize. Now, we've done problems like this before. We just like one of these things. And you're probably thinking, there's some basic simplification I can do just with that on that side right there. And that's totally true. If you start with this, you notice that both 6 and 21 are divisible by 3. So you can reduce that. You've got x to the fourth over x. So you can reduce that. And you've got a y and a y over y cubed. You can do some canceling out there too. I would suggest that that might be a good method to take on these problems, just to simplify it first before doing your multiplication. So, all right, well, let's do that. Divide everything out here by 3, and I'll get 2 over 7. I fix the x's. X to the fourth divided by x will be an x to the third up here. And the y divided by y to the third gives me y squared. Okay, fair enough. Well, now there's a second problem over here. And I've got 7s and 3s. Look at that. 7s and 3s, there's nothing to do there. But the x's, well, that can get simpler too. I got 2 in the top, 3 in the bottom. That leaves me with 1 in the bottom if I simplify. If I cancel out 2 out of the top and 2 out of the bottom. And the y's cancel each other out. So that simplifies down to that problem right there, which by the rule says I can go all the numbers and letters and stuff on the top and multiply them all together. That is, I can have 2, and I can rearrange the order and then put 7 next and have x cubed. And divide that by that 3 times the 7 and x and y squared. I got a little bit more canceling out to do. The 7's can cancel out. And I got 3 x's in the top and 1 x in the bottom. One of those x's can cancel out. I can have 2 x squared. That x cancels out over 3 y squared. Final answer. That's if I do the simplifying first. I could have just gone right here and smushed everything together. And so I'll do that this time. 6 times 7 is 42. X to the 4th and x squared is x to the 6th. Y and y squared is y to the 3rd. Over 21 times 3, which is 63. The x is combined to be x to the 4th. The y is combined to be y to the 5th. Then there is some simplification here. 2/3, 21. Divide both these by 21. I get 2/3. I divide the 6 x's by the 4 x's here, and I'll have x squared. And I'll divide the y cubed by the y to the 5th. That gives me y squared at the bottom. So I can combine and then simplify. It's still the same thing. This other problem is almost exactly the same, except I've got to fix this first. I've got to rewrite this part right down here. And I got to put this off to the side so I know what I'm doing. X squared y, x cubed y squared. Okay, so I'm going to change this to multiply, and I'm going to invert this whole thing. I'm going to take its reciprocal. That is 2 over 5, an x cubed, a y squared, and x squared and a y. Your choice again, would you like to simplify these first, or would you rather combine them and then simplify at the end? It matters not, but I can see that 5 there and a 5 there are going to cancel, and 1 there and 2 there. So all the numbers are really simple. I'm going to have x, and x to the 3rd makes x to the 4th. Y to the 4th and y squared is y to the 6th. On the bottom I have a 2. And then I combine the x's to get x to the 4th, and the y's combined to make y squared. Those x's are the same powers, so they'll cancel out. That equals 1. And I can reduce this a little bit as well. Take off 2 off the top and the bottom. Y to the 4th divided by 2. Final answer, much more simple in the answer. Just a lot of collecting of stuff and then simplification. Or simplification and then collecting of stuff and maybe some more simplification. That might be an option as well. Multiplication and then division, which turns into be a problem that ends up being multiplication anyway, just multiplying by a reciprocal. Let's get a little bit funky here, and we'll put in some polynomials. That's coming up next. Okay? Go back and rewatch any of that if that was completely confusing. I'm juggling imaginary balls. Isn't that cool? I'm working at it all my life. Got 2 problems here that involve polynomials. That would be like this, where you got a sum or a difference of parts. It's got 2 parts. This has 3 parts. And right off the bat, this looks like it's going to be a really confusing question. There's a couple things I do the top equation first, and that would be I put all this up there like it's one big factor and put it over 1, so kind of I see numerator and denominator. Now I could go 9 times all this stuff over this thing here, but for me, this thing is screaming for me to factor, okay? I can see this is factorable, simplify that part, and then this is factorable too. We did these the other day with breaking it up into 2 pieces, like regrouping. So I'm going to do that. I'm going to take this one down here. I'm going to say, well, that's 3 times x minus 5. rather than that thing. And up here, that factors down. I got 1 times negative 15. And I want to find the factors of negative 15 that would add up, that would sum to negative 2. 3 times 5 plus 3 minus 5 multiplies together to make negative 15, but would sum to negative 2. So there they are. X plus 3, x minus 5. Replace that, replace that. My new problem is 9 over 3 x minus 5 with an x plus 3 and an x minus 5. Not much. Oh, wait, look at that. There's 2 x minus 5s now. They can cancel out because that equals 1. And I can reduce this to 3 over 1. And there's only one thing left, and that's right there. That's way simpler. Look at that. X plus 3 is an answer. So I can't see if there's anything to factor or anything that's going to cancel out there because it's too complicated. If I simplify that by grouping or regrouping, I can see there's a common factor in the numerator and the denominator when I've combined those that can be factored out. Lovely, wonderful, super, great. Oh, golly. Love pencils. Way better. Here, same thing. I can't really tell if anything's going to cancel. And if I cancel now, I'm in big trouble because there's sums in there. I need factors, for crying out loud, so I'm going to factor this thing. Can I factor this? Well, yes, I can. There's a common factor of 2, of m, and of n. And if I factor out that and see what's left over, I'm left with 4 and m. And then everything got factored out of there, so that leaves me with 1. That's what that turns into. 2mn with m, 4m plus 1 left over. Now they're all factors. Over here, can't factor that, but I can factor this. Both of them have a 6 factor in there and an n factor. And after that, I'm left with 4m plus 1. So if I go across now, my problem is 2mn times 4m plus 1, 15. And on the bottom, I'll have 2m. I'll have 6n. And I'll have 4m plus 1 because I can just multiply straight across the numerator and multiply straight across on the denominator. 2's cancel out. M's cancel out. N's cancel out. 4m minus 1's cancel out. And I'm left with what? I'm left with 15 over 6. And I can do just a little bit more because they're both divisible by 3. That reduces down to 5 over 2. There are no more letters involved. Everything is factored out. There'd be no way for me to know for sure what would cancel and factor if I had that for starters. What a mess. What a mess. But that, much better. And it's so satisfying to like, jump you out of there! I karate mathematical you! You wakda! Take you out. Equal to 1. Don't need you anymore. There we get final answer. Feels so good inside. And that's it. All the other ones are just going to be various versions of those things. But my advice to you is this. Factor first. Look for factoring. Factoring is a form of simplifying. Do it. Do it. You will thank me later. The application problem is likened unto that. Check this out. Man, factor first, people, and you will be happier for it. Thank you very much. Leave a comment. Oh, you're probably not allowed to do that anymore. Yeah. Hey, see you in class. Maybe you'll have some questions. Love to answer them. Thanks for watching.